Varignon's theorem. This topic you will find in the chapter of statics. This theorem is about torque. You know that for translatory motion to initiate or to accelerate, force is required. Without the application of force, acceleration or retardation is not possible. And if a body is at rest, no further movement is possible. To change this state, force is required. Similarly, for rotational motion, what is required is the name of which is torque. Torque means moment of a force. In Varignon's theorem, it is stated that suppose there are two coplanar forces acting through a point. Coplanar forces means both the forces are lying on a flat plane. Okay. They are coplanar and they are acting through a point. Common point is there. Acting through a point. And an angle is in between there. Between them. One angle is there. So you know that you will get one resultant force using that two forces. Now on the same plane you take any other point, not that point of intersection of the two forces, not that point, okay? Take any other point and calculate the algebraic summation of the moment of the forces or algebraic summation of the torques. How it will be measured? Force, magnitude of the force multiplied by the perpendicular distance. Which perpendicular distance? It is from that point about which you want to calculate the moment. From that point, you draw one perpendicular on the line of action of the force. So that perpendicular distance multiplied by the magnitude of the force. That is the moment of the force. And now take algebraic summation. Here algebraic summation means what? You have to consider the direction of the moments also. Moments may be positive with respect to that point. Moments may be clockwise, moments may be anti-clockwise. Normally, anti-clockwise moments are taken to be positive, and clockwise moments are taken to be negative. And you know this thing that if you take the opposite convention, still there will be no problem. But clockwise moments and anti-clockwise moments, they should be opposite to each other. Okay. So suppose for our example, we are taking anti-clockwise moments to be positive and clockwise moments to be negative. Now, so using those two forces, say the forces are F1 and F2 and corresponding perpendicular distances are R1 and R2. So, moments are R1 F1 and R2 F2. Okay. And now, draw the resultant of the two forces F1 and F2. Say the resultant becomes F. And the corresponding perpendicular distance from that point, the same point, is R. Then moment of the resultant force about the same point is R into F. Okay. Now according to Varignon's theorem, this R into F, moment of the resultant force about that point is equal to the algebraic summation of the moments of the two forces. F1 and F2. Suppose R1 F1 that moment is anti-clockwise, and R2F2, that moment is clockwise. And also you have to consider the direction of the resultant torque, resultant force, moment due to the resultant force. You have to consider the direction of that thing also. Suppose that is anti-clockwise. Okay, suppose that is anti-clockwise. Then you have to write R1F1 minus R2F2. R1F1 is anti-clockwise, so I have taken to be positive. R1F1 minus R2F2 is equal to RF. This R1F1 minus R2F2, this is the algebraic summation of the forces of the components. And RF, this is the moment of the resultant force. So this thing can be proved very easily using vector algebra. If you know vector algebra, this thing can be proved very easily. Anyway, if number of forces is not 2, it is more than 2. It may be 100, it may be 1000. Suppose there are n number of forces. So in that case also, same principle can be applied. Okay, suppose there are n number of forces. So algebraic summation of the moments will be R1F1 plus R2F2 plus R3F3 like that up to Rn Okay, that will be the algebraic summation, and resultant force is F, corresponding perpendicular distance is R, then R into F, that will be the moment of the resultant force about the same point. So both will be same. Now, when a body is in static condition, is at rest, we are dealing with now problem on statics. Okay. When a body is at rest, you know that there will be no net torque acting on the body. Maybe there are thousands of forces acting together, but there will be no net torque. If net torque exists, then there will be rotation of the body. Okay, since the body is not rotating, it is at rest condition, therefore resultant torque must be 0. Okay, that means for the problem on statics, you take algebraic summation of the moments and make it 0. Make it equal to 0. So if there are two forces, then R1F1 plus R2F2 or R1F1 minus R2F2, considering the directions, you will get positive or negative sign. This is the algebraic summation and make it 0. So that is one necessary condition for a body to be at rest condition. This is Varignon's theorem. Is that clear to you? If you find any difficulties in understanding this theory, you can write me in the comment box. This video is will be uploaded to YouTube channel. You will find it is in Ma Durga Physics. And the same thing is available in my blog also, in my website also. Website of this blog will be given in the description box of this video. Okay. And in that website, the same theory you will get in 3 languages: Bengali, Hindi and English. Bengali, Hindi and English. Same theory you will get in 3 languages. Language will be mentioned. For each video, language will be mentioned. So according to your language, according to your choice, you can select, you can watch the video. And if you like the video, please press like button. And if you want to subscribe, if you want further videos to watch, then please subscribe the channel and press the bell icon so that you will get notifications for newer videos. Okay. Thank you.